Hello, welcome to this second video on the negative binomial distribution. Here's an example, that typical kind of exam question, I suppose. Charlotte always chooses tea from the drinks machine. The probability the machine gives a good cup of tea up to Charlotte's standards is 0.75. Each occasion she buys a tea is independent. So the model works. What is the probability that Charlotte's 7th nice tea comes from the 12th purchase? Well, that means she wants 7 nice cups of tea, but it takes her 12 times to get to that exactly. So, well, first of all, we're looking at X is the number of times it takes to get 7 nice teas. That's negative binomially distributed. We're looking for 7 successes, and the probability of success each time is 0.75. So we've looked at why this works. Now let's look at just applying it in a contextual situation. So we want the probability that it takes 12 purchases exactly is 11, which is 12 minus 1. Choose 6, which is 7 minus 1. Remember the formula, which I've just put here as a reminder. We're going to multiply that by the probability of success, 0.75 to the power of 7, the number of successes, times 0.25 to the probability of 5, which is the number of failures. Stick that in your calculator, 3 significant figures. Your answer should be 0.602, so a little over 6%. There we go. Okay, now we introduce a bit of conditional probability. We've got the same setup, but this time we're introducing a condition. We're saying, given that the first cup Charlotte buys is nice, what's the probability that Charlotte's 7th nice cup comes on as 12th purchase? It's going to be a little bit different to the last probability because we've already got the first one decided. So we're actually interested in 11 times she's purchasing. So we introduce a new variable, that's this y. Now, y is the number of attempts after the first attempt needed to get 6 nice cups. Well, the first was nice, so now we only need 6 nice ones. So you do have to think a little bit. So y is a negative binomial distribution. This time we need 6 successes because we know we've already had 1 success towards that 7. This is still 0.75 though. So we're interested in the probability that I've got 11 goes. On the 11th go, I get my 6 success, and therefore 7 overall, because the first one's decided. It's a bit of a thinker, this one. Right, let's apply the formula. So the probability of 11, we want y to equal 11. We want the 6th success on the 11th go, because we've already had that 1 success. So it's going to be 10, choose 5, 11 minus 1, over choose 6 minus 1. Then we multiply that by 0.75, the probability of success to the power of 6, 6 successes, times the probability of failure, 0.25 to the power of 5, which is the number of failures. And let's see what that gives. Okay, it's 0.0438 to 3 significant figures. So a bit over 4.3%, just 4.3, 4.4% around that, just so it feels a bit more real. Now this was a tricky example. We already know Charlotte's first cut was nice. We need the probability that the 7th nice T comes from the 12th. So we're just interested really in terms of the probability model in the 11 times after the first. The first is already decided. So it becomes a question of, well, can I have my 6th success on the 11th try? Well, that's the end of this example session on the negative binomial. I hope it made sense. Thank you very much.